Today, we are tackling a big one, a word that has absolutely taken the tech world by storm: Kubernetes. You've probably heard it, but what is it really? Is it just hype, or is it actually the future of how we build and run our software? Well, let's find out. So here's our game plan. We're going to start with the big picture, then we'll zoom right into the guts of how it all works. And finally, we'll get to the practical stuff. Is this actually the right tool for you? Let's do it. All right, let's get right to it. For years, applications were built as these huge single units. We call them monoliths. But the modern way is to break them up into all these tiny independent pieces called microservices. And that created a whole new problem. How in the world do you manage hundreds or even thousands of these little pieces? And that right there is the exact question that Kubernetes was built to answer. So when you strip away all the jargon and all the hype, what is it really? Okay, here's the textbook definition, but let's translate that. Imagine you have an orchestra of applications. In today's world, those apps are neatly packaged into these little boxes called containers. Kubernetes is like the master conductor of that orchestra. It's the system that tells all those little boxes where to go, how many copies of each to run, and how they all talk to each other. And it does it all automatically. It's the brain working behind the scenes, making sure the entire symphony runs perfectly. And here's a fun fact for you. Kubernetes actually has its roots deep inside Google. It's based on an internal system they had called Borg, which ran their massive applications for more than a decade. Oh, and that little nickname you see everywhere, K8S, it's just a simple shorthand. You have the letter K, then 8 letters, and then the letter S. Pretty clever, right? Okay, so now we know what it is and why it exists. So let's pop the hood and see how this thing is actually put together. We're going to zoom out and take a look at the high-level architecture of what's called a Kubernetes cluster. And honestly, this is the absolute simplest way to think about it. Every single Kubernetes cluster has 2 main parts. First, you've got the control plane. That's the brain. It makes all the decisions. Then you've got the worker nodes, and that's the muscle, doing all the heavy lifting. Now, here's a really interesting little detail. What does the muscle actually run? It's not just containers directly. It runs something called a pod. I want you to think of a pea pod. It's this tiny wrapper that can hold one or even a few containers that really need to work closely together. And this pod, this is the smallest, most fundamental building block in the entire Kubernetes universe. Everything, and I mean everything, is built on this one simple idea. Now that we understand that basic building block, let's go meet the management team. We're diving deep into the brain, the control plane, to see the key components that are making all the critical decisions for the entire cluster. So inside that brain, you've basically got 4 key players. The API server, that's the front door. It's the only way you or anything else can talk to the cluster. Then there's etcd. Think of it as the cluster's official memory. It's a super reliable database that stores the state of the entire system. The scheduler is like a dispatcher. It sees new pods and figures out which worker node is the best place for them to run. And finally, the controller manager. It's like a thermostat, constantly checking to make sure the cluster is running exactly how you told it to. So we've met the brain. Now it's time to check out the muscle. The worker nodes are the actual machines. They could be physical servers or virtual machines that are running your applications. This is where your code actually lives and does its job. And on every single one of these worker nodes, you'll find these 3 essential pieces of software. First is the kubelet. That's the agent on the ground that takes its orders from the control plane and makes sure the right containers are running. Then you have the container runtime. That's the engine that actually starts and stops the containers. You might know it by names like Docker. And last, you've got the kube proxy. This is the networking wizard, managing all the traffic rules so your pods can talk to each other and to the outside world. Okay, so we get the architecture now. It's brilliant, but it's also a lot. And that brings us to the most practical question of all. Why would you use this? Because, like everything else in engineering, it's all about trade-offs. So let's weigh the incredible power of Kubernetes against its very real price. So here it is, the big trade-off. On one side, Kubernetes is an absolute powerhouse. It's built for huge scale, it can literally heal itself if a server crashes, and it's portable. You can run the same setup anywhere. But on the other side, its number one drawback is a giant one: complexity. It is a beast to set up and manage correctly. For smaller projects, it can really be like using a sledgehammer to crack a nut. Which brings us to our final section. Now that we understand the tech and we understand the trade-offs, let's figure out if this incredibly powerful but also incredibly complex tool is actually the right choice for you or your team. This is the real bottom line question, isn't it? After all this, when does it actually make sense to take on all the complexity that comes with Kubernetes? And this table honestly lays out the answer perfectly. For a small company or a startup, the recommendation is often YAGNI, which stands for you ain't gonna need it. The overhead is just, it's not worth it at that stage. Now, for a mid-sized team that's starting to grow, a managed Kubernetes service from a cloud provider like Amazon's EKS, Google's GKE, or Azure's AKS is usually the sweet spot. You get all the power, but you don't have to manage that complicated brain yourself. And finally, for huge enterprises, they've got the scale and the engineering power to justify either managing it all themselves or using a managed service. So we'll end on this thought. Kubernetes is without a doubt complex, but it exists to solve an incredibly complex problem, running applications reliably at a massive global scale. Which kind of leaves us with one final question to think about. Is this level of complexity simply the price we all have to pay to build software for the modern world?